Hello Year 9s and welcome back to Mathemagic. In today's lesson we're starting a new topic of properties of geometric figures, and what we're actually looking at in this topic is angles within different shapes, within different in pictures and in different scenarios. And what we want to be able to do is figure out what the size of particular angles are. And so in the beginning of this topic we're going to be looking at calculating missing angles in different shapes, and what we need to do is be able to identify a few special angle relationships that we notice with different shapes. So what we're doing here today's lesson, we're reviewing basic angle relationships and also triangles. So we want to be able to find basic missing angles and identify types of triangles, and then find the missing interior and exterior angles in triangles. This might be a little bit of a longer video, so please do bear with me, and if you need to pause at any point during the video and watch back on previous parts, feel free to do so. So let's get started. The first thing we're going to do when we're talking about angles is we need to be able to actually name an angle, or specifically specify what angle we're talking about. Now with any angle, an angle is actually made up of two rays or lines. So here, if I draw up these two lines, I've got a line that connects between A and B. So these 2 points, A and B, we use capital letters to refer to them. And so an angle is actually made up of 2 lines and 3 points. So if you have a look here, I've got those 2 lines and the 3 points here, and we've created an angle over here. And the way that we can name this particular angle, so if we're trying to specify and particularly talk about this angle over here, the way that we name this is we use the 3 letters of the points around our angle here. So this angle here would be called angle, and I use this symbol here. This looks like a weird L shape. This is just a symbol for angle. So I'm going to put it here. This is angle. And I'm going to write here, this is angle ABC. The important thing when we're naming an angle is that the middle letter is the corner or vertex, which is where the angle is at. So if you have a look over here, the angle is at B. And so when I'm naming my angle here, this angle is called angle ABC, and B is the important letter here. So B is the vertex where the angle is located. And the 2 other letters just tell me where the kind of 2 other lines of my angle are located. So here we're going from A, B to C. So that's the angle notation that we're going to be using within this topic. So that's just when we're referring to angles later on. And so we're going to be coming back to this angle notation as well throughout this lesson, throughout this topic when we're referring to specific angles. Now the first thing we're going to do is we need to recall a few basic angles that we need to actually be able to identify. Now I'm actually going to go through quite a few. I'm actually going to go through 7 of them, but out of those 7 we're actually only going to be using 4 of them to help us find missing angles. So let's just have a talk about a few angles here. Now here I've got a whole bunch of different shapes and angles in particular, and so let's just go through each one of them and what they are. So for this first one, if you remember, this particular type of angle is an acute angle. An acute angle is an angle which is between 0 degrees all the way to 90 degrees. And so an acute angle is an angle which has a size between 0 to 90 degrees. So if anything from here all the way up to here, that's 0 degrees all the way up to 90, that is an acute angle. The next one is one that you probably have seen before. This is a right angle. And so here, this is a right angle. And so the thing that tells me that this is a right angle is this little square box at the bottom. This is a symbol that we use to show that something is a right angle. And with any right angle, it is 90 degrees. Now with right angles, there's actually a special word that we actually use in mathematics, which means is complementary. So if 2 angles are complementary, what that means is that they add up to 90 degrees. So if you see this word complementary, it means 2 angles add up to, let me just give myself a bit more space here. So complementary is a special word that we use to refer to 90 degree angles, and it means that we add up to 90 degrees. So if 2 angles are complementary, it means they add up to 90 degrees. Okay, The third angle here, I'm just going to kind of quickly go through this. This third one is called an obtuse angle, and hopefully this one is another one that you are familiar with. An obtuse angle is an angle which is between 90 and 180 degrees. So 90 to 180 degrees. Maybe I should put these dots here. Maybe I'll do it like this. Right angle and acute angle. Okay. So if your angle is between 90 degrees to 180 degrees, it is an obtuse angle. Okay, that's our first three. The fourth one, we call this there's a few ways that you can refer to this particular angle. I call this angles on a straight line or a straight angle. I call this angles on a straight line, or you could also call this a straight, straight angle. And if you have a look here, angles on a straight line, they add up to 180 degrees. So if you see a straight line, that means that the angles on that line add up to 180 degrees. And just like the 90 degree angle, there's actually another special word that we use here, which is called supplementary. So if two angles are supplementary, what this means is that they add up to 180. So add up to 180 degrees. So if you've got two angles that are supplementary, it means that they add up to 80 degrees. They kind of fill this criteria here. So angles on a straight line. Let's keep going. The next one here is number 5. This one is called a reflex angle. And so with a reflex angle, that is an angle which is between 180 degrees and 360 degrees. So if your angle is between 180 and all the way to 360 degrees, that is called a reflex angle. Now the final one is this particular point here. Now here I've actually drawn a few angles at this particular point. And there's a few ways that we can refer to this angle. This is sometimes called angles at a point, or angles at a revolution, angles of a revolution. Both of these are kind of the same thing here. And so here, whenever you see a point here and multiple angles around the particular point, there's actually 360 degrees there. So a full 360 degrees is a full rotation around the point. It's called an angle, angles at the point, or an angle of a revolution. Now there's another one that I've actually included here, which isn't quite the same. If you've got this X shape here, so if you've got an X shape here, run out of pen colors, oh there we go. If you've got this X shape here like this, and you've got two angles opposite each other, these two angles have a special relationship as well. These are called vertically opposite angles. And the thing about vertically opposite angles is that they are equal to each other. So these two angles are equal to each other. So the two angles that I've highlighted in red, those two are equal to one another. So here, these are a few just basic angle relationships, angle shapes that we need to be aware of. But in particular, I'm actually going to highlight 4 of them that we're going to be able to use, that we need to use. In particular, we're going to need to use the right angle. So we need to identify that at a right angle, it's 90 degrees. The second one is angles on a straight line. If you see a straight line, the angles on a straight line add up to 180, or they're supplementary to one another. The other one is angles at a point, or angles of a revolution. So angles of a revolution, they add up to 360. And the final one is vertically opposite angles. So these 4 angle relationships are the ones that we're going to be actually using to help us find missing angles. So let's actually have a go at using these particular angle relationships to help me find missing angles. What I have here is a few steps that help you out as you're doing this. So what you want to do, the first step is just to identify what type of angle type you have. Do you have a right angle? Do you have angles on a straight line? Do you have angles of a revolution? And just have a look at the angles that you're given. Sometimes a diagram might actually have other angles that you might not be interested in. Just have a look at the angles that you have and the angle that you're trying to find. Then what we want to do if we're trying to find a missing angle is to write an angle equation involving the types of angle included. So if they add up to 180, for example, what you just want to do is just list out all your angles. So like, for example, a plus 30 is equal to 180 degrees, and so on. And then the final step is that we solve for our unknown angle. So I'm going to go through a few examples. I'm trying to go through those steps because whenever you're trying to solve for missing angle, we're actually going to be using these kinds of steps to help us figure out what the missing angles are. So let's have a look at finding missing angles in these basic shapes. So first one here. We have this diagram here, and we've got a few pieces of information. If you have a look, this type of angle is a 90-degree angle. So if you have a look, it's a 90-degree angle. And the way that we know this is that we have this square box here. But with this 90-degree angle, hopefully you've noticed that here we've got two angles inside it. We've got angle A, which we want to find, and we've got this 60 degrees. So both of these angles make up that 90 degrees. And so these two angles are examples of complementary angles. They add up to 90 degrees. And so what I'm going to do, if I want to find the value of A, what I'm going to do is I'm going to write an angle equation. I know that A and 60, they're inside that right angle. And so what happens is if I add up those two angles, A plus 60 degrees, well, because they are on that 90-degree angle, they need to add up to 90 degrees. So here I'm going to put in that equal to 90 degrees because of that right angle. And here I'm going to actually give the reason on the side here. This is a right angle. Okay, now that I've written this, so this is I've identified the angle. I've identified what my angles are. So I've identified the shape of the angle. And I've identified what angles I have inside my shape. And so now I'm just going to start, and I've written my angle equation. What I'm going to start to do is just solve for it. So here, if I want to solve for A, I'm just going to move this plus 60 over to the other side. So A is going to equal to 90 minus 60 degrees. So that is going to be 30 degrees. So A is 30 degrees. Okay. So that's how we can find missing angles on these particular shapes. Okay, let's have a look at the second question. Now, the second question, here we actually have two missing angles. And what we're going to do is we're going to find each of them separately. Now here, if you have a look at my diagram, I have this X, and on one side of my X I have, and I wrote this a little bit terribly, 50 degrees. And I've got my two missing angles, A and B. So let's have a look at A. Now, if you have a look at A and that 50 degrees, the only thing that we can work off of is the fact that there's that 50 degrees there. And so if you have a look at this diagram, it kind of looks like my vertically opposite diagram. I have an X here that separates one, I have an X here, and I've got two angles on opposite sides. So I've got my A and I've got my 50 degrees. And so because they're on opposite sides of this X, that means they're vertically opposite angles. So what I can do here is just by identifying the shape, I can just say that, writing my angle equation, A is going to equal to, A is going to be equal to 50 degrees because they're vertically opposite angles. So if you have a look at the shape of the vertically opposite angles, if you've got an X and you've got the two angles opposite each other on the X, that means they're vertically opposite. So here I'm just going to write A is equal to 50. They are vertically opposite angles. Okay, so that's how we can find that particular first angle. Angle A is just in 50 degrees. They actually make up that vertically opposite angle. Okay, now we also want to find, oh, let me try and undo that one. Let's see if I can do that one. There we go. Now the second thing that I want to do now is finding the angle B. Now if you have a look at the angle B, B and 50 degrees actually make a particular shape. If you have a look here, they're on the same line. Now, because they're on the same line, that means there is a straight angle here. So B and 50 are going to add up to 180 degrees. Oh, actually, I forgot this should be example number 2. B and 50 are going to add up to 180 degrees. And so because they are on a straight line, the same straight line together here, they should add up to 180 degrees. They're supplementary angles. So what I'm going to write here is B plus 50 degrees is going to equal to 180 degrees because of angles on a straight line. Because they're both angles on a straight line, they're going to add up to 180 degrees. So that's why I've written this in this angle equation. So once I've done that, I'm just going to move this 50 over to the other side. I'm going to subtract it. So B is going to equal to 180 degrees minus 50 degrees. And so B is going to be 130 degrees. Okay, so that's how we solve these particular questions. So here we had to identify that vertically opposite angles are opposite each other on the X. And so if you've got two angles on opposite side of the X shape, they're going to be vertically opposite. And the other thing is that B is on the same line as 50. And so because they're on that same line together, that makes up 180 degrees. Okay, let's have a look at example 3. Example 3, if you have a look here, we've actually got 3 angles involved. Here we've got a point. And so if you've got this point and you've got angles around that point, they're going to add up to 360 because of our angles of a revolution. And so here we've got our missing angle A, we've got 115, and we've got this square box over here. So if you remember, that square box just means that we've got 90 degrees here. And so, because they are around this one particular point and they are around this point in the center, they're going to be an angle of a revolution. So what I'm going to write here is when I add up all these angles, they're going to add up to 360 degrees. So here is going to be A plus 90 plus 115 degrees is going to equal to 360 degrees. So the reason is because they are angles of a revolution. So if you have a look at the angles of revolution, if we have any angles around a particular point, so any angles around one point, they're going to add up to 360 degrees. So here, this angle over here was 360 degrees. Okay, and so once I've done that, I'm actually going to start to solve for A. Now, when I solve for these particular equations, there's a way that I usually prefer to do it. I prefer just adding all the numbers on my left-hand side first and doing one subtraction. So here, what I'm going to do is I'm going to add the numbers on the left-hand side. So here I've got A plus 90 plus 115 will actually give me 205 degrees. And on my right-hand side, I've still got 360 degrees. And then now I've done that, when I move this, I can move this over to the other side and subtract it. And so A is equal to 360 degrees minus 205, and so it gives me 155 degrees. Okay, so that's how we use these that's how we find these basic angles. We first want to identify what type of shape we have, and then once we've identified what type of shape we have, we are then going to once we've identified what shape we have, we just use that particular angle size to help me figure out what we have. So if it's those missing angles. So for example, here I've got a 90 degrees. I've got a right angle, which means it's 90 degrees. Here I have this, firstly, a vertical opposite angle. So the two angles opposite each other are going to be equal. But I've also got a straight line, which means that the angles on my straight line will add up to 180. And the final example here, we have angles around a point, which means they add up to 360. Okay, so that's this first part of this lesson on finding basic angles.